Yes, my dear students, today let us go for experiment number 1. Here the aim is to determine the thermal conductivity of a metal rod. The metal rod is made by brass. Okay, apparatus, stopwatch and water beaker. Theory you have to write by referring this manual. Next procedure. Procedure wise, number 1, check the water in water tank provided at the top of setup. 2, switch on main power supply and adjust the dimmer stack to 50 volts and wait minimum 40 to 45 minutes until steady state of current flow reached. And 3, take the readings of temperatures of different points along length of metallic rod by operating temperature switch. 4th one, at the same time, take the temperature of hot and cold water and also mass flow rate of water in the beaker by counting the time with the stopwatch for minimum of 20 mm of water level in the beaker. And next, 5th one, continue the experiment for different voltages like 60 and 70 and so on. Then calculate the thermal conductivity by referring table of readings with equations. Okay, so the table, actually the reading table you can refer in the manual. Okay, next equations, we have to take the balancing of heat flow. Here heat conducted through metallic rod equals to heat absorbed by the water. So heat conducted through metallic rod is Ka dt by dx. You don't doubt about this negative sign, it only indicates degrees of temperature with increase of length. So next equals to mc, the heat absorbed by the water, that is mcp twh minus tcw. twh means hot water temperature, tcw means cold water temperature. Mass is the m is the mass flow rate, cp is the specific heat of the water, that is 4.187 kilojoules per kg Kelvin. Okay, so next, therefore by equating this equation we will get equation K equals to mcp twh minus tcw divided by A into dt by dx. But dt by dx we can take from the graph. We can plot the graph of temperature versus different points along the length of the metallic rod. So along y we will take the temperatures T1, T2, T3, T4, T5, and along the x-axis we take different points along the length, means thermocouple points along the length of the metallic rod x1, x2, x3, x4, x5. So corresponding to these distances we take the temperatures T1, T2, T3, will get a slope. So from this slope we can get dt by dx. This value by putting here we get the thermal conductivity of the experiment. So this is about theoretical aspect and how to go for the experiment. But now let us come to the experiment here. So here we see the temperatures and volts and currents are displayed on the board. This is the tank, water tank provided on the top of the experimental setup. Here metallic rod is inserted into the insulating box. The length is given. We will go to divide that length into at different points like T1, T2, T3, T4, T5. So total length whatever given inserted into the insulation, but one end of the rod is connected to the heater and another end of the metallic rod is inserted into the water jacket. Here the water from the tank will flow through this water jacket, and then by absorbing the heat from the metallic rod it flows out into the